Hello, everyone, and thank you for joining us for the fourth installment in our 20-part series of webinars on climate action. My name is Robert Ulley, FAIA, and I am the AIA California Vice President for Government Relations. And I'll be your moderator for today's segment. As you know, AIA California has developed this series focused on understanding and implementing AIA's framework for design excellence. This series will run through the end of the year. The series will feature monthly hour-long general climate action webinars and 90-minute webinars that dive deeper into the technical topics such as the one presented in today's panel of experts. All webinar content will be available on the AIA California website. And to ensure that you receive the latest information about this series and other AIA happenings, subscribe to AIA's weekly newsletter Relevance by visiting aiacalifornia.org. A few quick housekeeping reminders to get us started. You can find refreshments in your kitchen, and you know where the bathroom is in your house. Today's session qualifies for 1.5 AIA HSW learning units for watching live, and AIA California staff will take care of reporting this for you. This session is also being recorded and will be posted on the AIA California website with additional resources and a PDF of the presentation shortly after this session. And as a reminder, please use the Q&A function to ask any questions of today's panel. Using your Zoom controls, you can also like a question to move it to the top of the queue. All attendees will be muted for the listening comfort of all of us. Now on to today's webinar. When thinking about designing for economy, we should focus on how good design adds value for project owners, occupants, our communities, and our planet, regardless of the size of the project or its budget. Passivhaus is not just limited to the residential market, it covers all building types. How much will it cost to build using Passivhaus standards? How do you plan and build multi-passive housing for less than other similarly sized projects that are market comparable? Lessons learned and best practices used in the meeting the Passivhaus approach from concept to planning to completion will be presented by today's panel. An examination of why developers choose to use this voluntary standard and what the first generation multi-family passive housing building costs to construct shows that lowering the cost of planning and building high performance buildings makes sense. Our presenters are Colin Shane, PE, and Monte Paulsen, EA. Mr. Shane is a professional engineer practicing in the United States and Canada and is a principal in the San Francisco Bay Area firm of RDH Building Science Incorporated. Mr. Shane has a broad knowledge of building construction and applies building science principles to analyzing and design durable energy efficient building enclosures. He shares his experience by regularly speaking about the topic related to building envelopes at events across the United States and contributes to industry organizations like AIA with the aim of making buildings better. Mr. Paulsen is among Canada's most experienced Passivhaus professionals. He leads a multi-city Passivhaus team that has consulted on or certified more than 70 projects, totaling 4 million square feet. These include homes, offices, affordable mid-rise buildings, and luxury high-rise buildings. He is also a veteran Passivhaus trainer who has helped more than 100 professionals earn their certified Passivhaus designer credential. His courses range from a one-day Passivhaus 101 overview to the multi-day workshop, A Pattern Language for Passivhaus. Mr. Paulsen was a founding member and volunteer at the nonprofit organization Passivhaus Canada and previously managed his own Passivhaus consulting firm before merging with RDH in 2016. Welcome, gentlemen. The floor is yours.
Thank you all for joining us. I will share my screen to start, and Monte and I are going to go back and forth a little bit today on a couple different sections here. Just confirming everyone can see a full screen slideshow with a building on the right and a title slide on the left.
Yep, you're good.
Perfect. Well, thank you all for joining us. It was a great outline. I appreciate that, Robert. So I think we can dive right in. I hope to be fairly practical today. We want to talk about a bunch of real buildings. Monte's going to give quite a bit of discussion around costs and planning processes to help deliver these high performance projects in a reasonable, cost-effective way. And we're going to look at some real data and some real numbers. So I really do hope that it's practical for everyone from that perspective. And I certainly do encourage everyone to ask us questions in the chat box. Certainly makes it more enjoyable for us as presenters, and I hope more engaging for everyone else collectively, if we can have some back and forth discussion around some pressing questions that you all may have. So thank you for joining us, and we'll get started. Quick outline here. This is where we're going to go. I'm going to just give a background for those that may not be super familiar with Passivhaus and what it is and what some of the standards are. So hopefully we can get through that somewhat quickly and get into some of the meaty topics around budget. How much does building multifamily Passivhaus actually cost? I'm going to give some context around the California equation here, what a typical Passivhaus multifamily building might look like in the California climate. I think in many cases we think of Passivhaus and we think super thick walls and really expensive components, and all of those things may be true in harsh climates, but I certainly want to bring that home to a practical level. I'm San Francisco based, and Monte is in Canada, so there are real construction differences there just because of climate. So we're going to talk about that. Some milestones from a design process perspective. What do we have to think about at different stages of design? What goals do we need to reach? When do we need to make some decisions? And then just some key, 3 key takeaway strategies. If you fade away for the first 4 bullets here, come back for that strategies at the end, and hopefully some nuggets that you can take away with you. Just some background. RDH is a building science company. We focus on largely high performance buildings, but our technical expertise is really focused around facades and building enclosures and how that relates to whole building energy performance, how that relates to durability, how that relates to kind of all aspects of high performance design, if you will. So we consult on new buildings, old buildings, and do research work basically that can impact all buildings from a guideline and research perspective and things like that. So that's a little bit of background of us. If you're curious about our backgrounds, certainly feel free to check out our website. I'll skim over the intro of myself because Robert already covered that, but I'm San Francisco based. I manage our team here in the Bay Area. Monte, do you want to just chat a little bit more about yourself, or?
Sure, Robert did a pretty good job. I do lead Passivhaus teams across US and Canada. We've done quite a bit of work in the Northeastern United States in the last few years. I also lead the Global Passivhaus Happy Hour, which is a free drop-in on Wednesday nights for anybody who wants to attend. And I would just note that we work in both Passivhaus standards as well as other high-performance standards.
Awesome. Thanks, Monte. And these are some of your projects that you're currently working on. Unfortunately, we don't have any Passivhaus projects of this scale in California. I think we're limited to single family homes, although I do think that's changing, at least at the discussion level a little bit. I got an email from a client of mine yesterday actually talking about a multifamily Passivhaus that they're contemplating in Santa Cruz. So I think it's coming more closer to the forefront in California, which is exciting. But Monte, you just want to give an overview of what these projects are?
Sure. We see a real explosion here in Vancouver, driven, to be totally honest, in part by the fact that the city of Vancouver gives a small degree of floor space bonus for certified Passivhaus projects. And so at a building of this scale, that adds up to quite a few extra units. That's driving the boom in large buildings. Many of our mid-size affordability buildings, though, are being built pretty much at the same cost as others, as we'll talk about in a few minutes.
Awesome. All right, so really quick background for those of you that may not be intimately familiar with what Passivhaus is, or why it's important. We think it's a solution to many of the challenges. From Monte's context here, this is kind of the total energy use consumption of buildings in Canada. I think we all can appreciate that these northern climates are heating dominant largely. It's cold outside, so we spend a lot of energy heating in the winter and frankly even cooling our buildings in the summer in many cases in Canada. So that heating and cooling load is a fairly significant chunk of the pie. In California, certainly that dynamic shifts a little bit. The heating and cooling demand is less just because it's 70 degrees outside a lot, which is one of the reasons so many of us live here. But that heating and cooling is still about a third of the energy pie this is for single family homes in California. It's not an insignificant chunk. So there's a big dent there that we can look at from a heating cooling perspective, and minimizing that heating and cooling demand even in the California climate. This graphic above is from Southern California Edison. This is kind of a high level view of their strategy to tackle the climate crisis largely, talking about decarbonizing the electrical sector, going to renewable energy in that arena, electrifying the transportation sector as kind of another channel that they're focusing on, and thirdly, electrifying buildings. And Passivhaus, I think, is a way for us to really leverage that electrification of the building that's certainly getting a lot of press and push right now. Passivhaus lends itself quite easily to fully electric buildings, and minimizing that heating and cooling demand that's inherent in the Passivhaus standard helps us to electrify buildings in a reasonable, cost-effective way, and certainly minimizing the load on those, electrically heated and cooled buildings certainly helps with just the scale of the electrical sector that needs to ultimately decarbonize and make a significant shift over the next number of years towards renewable solutions. So I just want to make sure that Passivhaus isn't seen as another thing to tack on to these global strategies that are happening at the state level and the national level. Passivhaus fits really nicely into this plan of a cleaner grid and fully electric buildings. Really quickly, what is the Passivhaus standard? These are kind of 4 core criteria. I'll talk about the first 3. The fourth one is, we can get into those weeds if anyone has any specific questions. But the first one is a total heating and cooling demand over a yearly timeframe. How much energy can you pump into your building over the course of a year to heat and cool it? There's also a maximum amount of peak load that you're allowed to have while still meeting the Passivhaus standards. So some total demand, both on an annual basis and on a peak basis for heating and cooling, air tightness requirements, and then the primary energy renewable, which is some adjustments for how clean your grid is essentially. So quick example of what that peak heating cooling demand is for, let's say, a single family home at a couple thousand square feet. So if we take that peak cooling or heating load that we're allowed to have under the Passivhaus standard, we have a 2,000 square foot house. We take away some of our wall thickness and we get a net treated floor area that we need to consider. And the metric equivalent of that, I'm doing the math here in meters and watts. So that 3.17 kBTU is about 10 watts per square meter. That gives us about 1,750 watts as our peak heating or cooling load that we're allowed to have under the Passivhaus standard. That number may or may not mean a lot to some of us, but in simple terms, it's about that. It's about a hairdryer from a heating perspective. I have several hairdryer heaters basically throughout my house right now, and it's certainly hugely uncomfortable. It's 55 degrees outside and my house is freezing cold with all these basically hairdryer electric resistance heaters blasting full bore. So there's a comfort level aspect here too that I'm not going to talk about in detail, but the idea here is that we could, at a peak heating day perspective, heat our Passivhaus 2,000 square foot home with a single hairdryer or an equivalent amount of power. To get to that level, some key concepts that are consistent throughout all passive houses, regardless of where they are, is a thought around a fairly high level of insulation on the outside, and how high that is going to vary by climate, whether you're in Alaska or Southern California. We'll talk about what some of those typical ranges might be. A focus on air tightness, keeping the inside in and the outside out, so we're not reconditioning air that inadvertently works its way through our building enclosures. So we have tight building enclosures from both an air and a thermal perspective. Reducing thermal bridges is key so that we actually get the bang for our buck with the insulation that we're using and the air tightness measures that we're putting in place. Glazing, strategic glazing, using glazing where it makes sense. Glass is not a good insulator. It's not good thermally, and it can let in a lot of sun from a cooling load perspective. So we're not saying don't use windows, but use windows strategically and in places where they make sense. In colder climates, triple glazing is the norm here. In California, in many cases, we can get to the passive house standard with regular low conductivity double glazed windows. We'll talk more about that. Energy or heat recovery ventilation. We make this building airtight and we ventilate it specifically to the levels that we want. We're pumping in the right amount of air in an intentional way rather than just letting air flow through our buildings willy-nilly. So energy cover ventilation is a key factor here. And then once we've minimized all those loads, we can have really small and efficient electrically powered heating and cooling systems to manage the remaining load. Okay. So a bunch of reasons Monte spoke to the amount of passive house we have in the pipeline, design and construction in other markets. These are some reasons some of our clients are making that decision to go that way. Certainly there's the greenhouse gas, climate change perspective, easier to electrify like we always talked about. We'll speak more about the indoor air quality aspects of this a little bit later, but I think anyone who lived through last summer and fall and the wildfires or the last couple of years in California can probably appreciate the impact of that. Quiet and comfortable city living without the noise. Comfort is another one. I spoke to a colleague of mine who lives near Toronto now, but spent a couple of years living in Oakland. And even though he's lived in a cold climate his entire life, he told me that the most uncomfortable building he ever lived in was in Oakland. So I think maybe we've come to just tolerate that from a California perspective, but we can do better. Thermal resiliency, stepwise retrofits, collectively making our stock better over time. The third-party quality assurance aspects that come with a proven standard that's certified and is tested in real life. Future-proofing our buildings, training for what's coming next in 2025 and 2030 and 2035 if we're looking to push the envelope forward there. And Monte's going to speak a bunch about cost. One of the challenges I see, and I'm curious for others' perspective here, if there's any comments or questions, can we have our cake and eat it too? We have often, it seems, if you watch the news, these are just a couple articles that I found very quickly by Googling, these maybe competing priorities of our housing affordability crisis in California coupled with our climate crisis. Can we have both? Can we really solve the climate crisis and solve our housing affordability crisis at the same time? And I think in many cases, we think that we have to pick one. And we see that easing the building codes restrictions here is one of the ways that we can increase affordability. I guess part of our message here today is that we really can build future-proof, low greenhouse gas, passive house style buildings at an affordable price. So Monte, I'll turn it over to you, and I'll let you get into the nuts and bolts on costs from some other markets.
Great, thank you. Let me just get my screen share going here. It's a real privilege to be here. And let me just confirm that everybody can see my screen now. So the question I get asked most often is, how much does this cost? And what I'm going to talk about is construction cost premiums on multifamily buildings, not on single family. reported for recent projects in the US and Canada. These are not whole development costs. And obviously, at least in our market, construction cost is typically in the range of a third of overall development cost. So we're talking strictly hard costs. Short answer is 0 to 9%. On projects RDH is involved with, as we're hearing reporting from the architects and planners and consulting tables, we're hearing this range over the last 4 or 5 years. And one of our best competitors in the US, Stephen Winter Associates, which has projects primarily in the New York, Connecticut area, sees a really similar range, a range of between 1% and 8% construction cost premium in these colder, more challenging climates such as Canada and the Northeast. This tracks with a study on costs from the UK, looking at social housing developments that had to be built to certain standards. They found an average initially of 9% more than baseline, but as teams got into their second project, they were seeing cost premiums falling to closer to 4%. And we did a survey before we introduced our BC Energy Step Code, which by 2032 will require all of the new projects in our province to hit a metric very similar to the Passivhaus standard. So while it's not Passivhaus certification, it's 15 kilowatt hours per square meter per year, which is about 4.75 in IP that we described earlier. That survey of several studies also found about a 2 and 10% range predicted for Step Code 4 projects, with the northern projects costing more because they're colder. However, we've seen actual Step 4 projects coming in much lower than that range generally. So overall, our spread is in that 0 to 10% range. You can look at some of these studies. And if you're like me, you're a little doubtful, how can we do all these extra things without a cost premium? So I just want to kind of look quickly at 4 projects that have been completed, multifamily projects with real affordable targets. Starting with one here in Vancouver. This project was our first large multifamily Passivhaus here in Vancouver just a few years ago. Real typical form here, 5 stories of wood frame construction over a 1-story concrete retail podium over 2 stories of underground parking. This building, our first project, was a bit of a challenge because it was essentially retrofitted to Passivhaus. It had been designed and its initial submission to the city was based on conventional energy code. And so it was the first project for the architects. It was the first project for the construction team. The zoning required numerous setbacks and other pieces that in subsequent buildings we worked to simplify. At that time, there was only one appropriate heat recovery ventilation system in the market. So we didn't have the supply chain we have now, and only one appropriate window in the market. So we were limited at that time. It used a wall, and I don't think you'd have to do this in California, where the exterior was our typical 2x6 platform frame construction like we do mid-rise wood day in and day out, with additional insulation toward the inside. We've also added additional insulation to the outside. And again, I don't think you'd need this much extra insulation in most Californian climates. This gives a sense of what it looks like. The only real difference in construction was that you needed to wrap for air tightness around the header so that you can continue to layer up the inside of the next wall. That's what the inside of the wall looks like. Behind the 2x6, there is a thin layer of extra insulation and then some insulation in that service cavity. The other challenge, as I mentioned, was that we used residential scale HRVs from Zender, serving multiple units in stacks. It's kind of how we dealt with our first several multi-unit projects. We now have larger units from Swegan and Ventacity and Minerga in the market, and we've moved to those primarily. Nonetheless, great affordability at about $170 US, a little higher in Canadian dollars per square foot. The next building I want to just bring your attention to quickly is the Orchards at Orenco, which was built for about $158 per square foot a few years earlier. This building in Portland, Oregon, chose to use a 2x8, a little bit thicker frame construction with 2 inches of rock wool around the outside to eliminate some of the thermal bridging. So a different construction approach. Again, 57 units, $158 US a square foot. Little higher level of fit and finish. This was really a rental project for tech workers on the suburbs of Portland, working in many of the expanding tech companies there. And its second phase of that same project, by redesigning the unit slightly, had a little higher per square foot price, but a lower per unit price. Again, certifying as a Passivhaus building. Third project, I want to and I know I'm going quick, I want to point you to a project in Philadelphia. Capitol Flats was an infill site in a transitioning neighborhood, 25 one-bedroom suites, both passive house and net zero, completed at about 169 US per square foot, including the solar and the net zero features, or about 146 per unit. This project, like quite a few of the projects in Pennsylvania and parts of New York and Massachusetts, are using Build Smart panels. These are prefabricated panels that are relatively small. They can be usually walked to the edge of the building and positioned by a handful of workmen, so they don't need cranes to set them into place. They usually have the windows pre-installed, and then they can begin cladding and interior servicing usually within a few days. The Build Smart system works great for simple form multifamily, and then it manages costs and speeds lockup. This building also benefited not from using those little HRVs, but using 2 of these larger Ventacity HRVs on the roof, delivering great heat recovery and cooling recovery ventilation, which lowers heating and cooling loads quite significantly. And as Colin mentioned, can also filter out any exterior pollutants like smoke. Way simpler and generally more affordable to use a few large ones than many small ones. And then the prize winner for affordability of multi-unit Passivhaus in the last few years is in Portland, Maine. It's a project called Bayside Anchor, 45 units of family housing, infill at a social housing site, simple wood frame construction on a slab on grade, electric baseboards, gas domestic hot water, $149 a square foot a few years ago. Super simple fit and finish. This is affordable housing writ large, not even gonna spring for the cabinet doors. Really standard appliances, standard systems, a shared amenity space on the ground floor that is also used by some of the other social housing buildings on the site. And again, a really affordable, simple, might not win any architectural design awards, but in terms of delivering affordable housing in a tough climate to the certified Passivhaus standard is a real leader. Now, the point I want to make is that each of these were built below what was deemed as market rate for projects in the midpoint of the years these were built. And so if you look at the RS means data, in each case, these were beating the metrics they had to be and actually able to build below what other buildings are using. And so when we talk about some projects having essentially a zero cost premium for the Passivhaus standard, this is what we're referring to. I'm not going to spend more time on it now, but if you want to hear from a housing operator that's built serial Passivhaus projects, including the one in Portland, Maine, the green one we just showed, Avesta Housing is one of those operators. And there's a presentation about why they believe that even up to a 5% premium can be recouped in operations on the Passivhaus Accelerator website. The link's there in the lower right for this particular web, but if you go to the Passivhaus Accelerator website, search for Todd Rothstein or Avesta Housing, you'll find this 10-15 minute presentation, and you can let him walk you through that math a little more. Back to you, Colin.
Thank you, Monty. Maybe we'll just, as we're switching screens here, just solicit any questions and have some discussion if anybody wants to pause here for a second. Monty zipped through all those costs really quickly, so I'm sure people are have some specific questions about those.
You know, I'll just add to your comment on Mark's question that we're seeing more and more projects using panelization or modular. We've done several modular projects here in BC. It's really a market by market thing. Modular is a clear cost winner as we move to smaller communities that don't have diverse trades. And the biggest thing that's driving panelization here is the move to mass timber buildings in that kind of 7 to 20 story range. The mass timber needs quick enclosure, and so mass timber Passivhaus also needs quick enclosure. And we have several mass timber Passivhaus projects that are doing full panelization in design now, not yet any in construction.
Yeah, I was gonna, specifically to the modular and prefab question there. There's a big project in Boston right now that is incorporating mass timber panelization, volumetric modular into a large housing Passivhaus development there. Certainly in the Bay Area context, which is where I spend most of my time, in the we're seeing a lot of volumetric modular housing popping up all over the place throughout the Bay. I mentioned a project that's considering passive house right now locally. We'll get into the specifics on that, but the intention of that project is for it to be volumetric modular and passive house. So there are some real synergies there between the two, certainly. One of the things that we're going to talk about a little bit later is, and Monte spoke to it earlier, simple is really good from a cost effectiveness perspective. It's one of the reasons modular makes sense and it drives costs down, is because it forces us to be simple from a geometric perspective. That same geometric simplicity certainly helps us from a passive house and an energy perspective as well. So those two, in addition to mass timber, but many of those things are synergistic when you apply them together. So some California context. Certainly, Monte speaks from sits in Vancouver, and I having not always been from California, I appreciate that many of us think that, oh, that's something they do up there or in some other climates, but we can't really do that here. It's different here. I hope I've been around California long enough that I can speak to the California context. But the reality is our climate here is really, really moderate. We have 16 climate zones throughout California. And I picked climate zone 3 because it's where I live, on the peninsula, San Francisco, Oakland, around the Bay Area. This is our heating and cooling graph that's pulled right off the CEC Title 24 website here in heating degree days and cooling degree days. Monte probably chuckles at these numbers. These are, it's not that hard to heat a building here. It's not that hard to cool a building here. It's 65 to 75 a lot. And that should make it really easy for us to really drive down heating and cooling demand in this climate. It is. So what does that mean from a passive house perspective? How do we get to a passive house level of standard that heating on an annualized basis and on a peak basis? What do we need to do to get there for typical buildings in typical climates throughout California? This is a slide I took from my deck of from some passive house presentation I gave in a northern climate. And here are some of the wall assemblies that we start thinking about when you do this in really cold places. And many of us would look at this and say, oh goodness, not on my project, please, that looks complicated. Fair enough. Here are some of the details that we start thinking about maybe on some of these projects in Canada, northern parts of the US, in the Northeast. Thick levels of exterior insulation. This is a window sill detail where we've actually encapsulated the windows not sitting in there, but you can see the horizontal rough opening. A fairly common approach in some of these colder climates is to actually insulate on the outside of the window frame and bury that window frame in the wall assembly a little bit to minimize the thermal bridging around window perimeters. So these are things that are happening in other markets, and this can be scary if you've never done this before, and looks and maybe sounds expensive, whether or not it is or not. I think Monte has spoken to the data there that we can really do this at market rates in many climates. So, this is maybe what we think about when we hear passive house, is some big building with a really thick wool sweater on the outside and complicated details that are different than what we've done before. Passivhaus California and some other groups have been doing a whole series of studies around what it means to do passive house in the California climate. I mentioned previously, I was previously on the board of Passivhaus California, and there are still some fantastic individuals sitting on that group and pushing this initiative forward. But a study here, the title page off the study is there if anyone wants to Google it. What do we need to do from an insulation perspective to get to the passive house level in this climate? Surprisingly, maybe to some, in climate zones 3 through 10 and climate zone 14 in California. So that's essentially every climate zone along the coastal strip from San Francisco to San Diego, where the large majority of our population lives, where we're certainly building the bulk of our multifamily housing. In all of those climate zones, we can get to Title 24 that did some arch type modeling of typical buildings, of a model of a standard building. Certainly every building is different, so I don't want anyone to come to the conclusion that every building is going to work this way, but in an arch type study, we can get to that passive house level of performance with Title 24 prescriptive levels of insulation in our walls and roofs. So we're talking about 2x6 walls with a layer, one level R4 insulation on the outside, maybe up to R8 or R12 of insulation in our colder climate zones in the Central Valley around Sacramento, and certainly in the Sierras, where we get much more of a northern type climate as we get up higher in elevation. We're talking double glazed, low conductivity window frames with low E coatings in all these climate zones along the coast. So U.3 or U.25 windows, again, not numbers that are foreign to us if we're building code compliant buildings to Title 24 right now. So we're not seeing this from a design perspective for assemblies in California. We are seeing assemblies that might look like this. It might be as simple as 2x6 with some advanced framing techniques. It might be 2x6 on its own. It might be 2x8 with bad or blown in insulation. It might be stud framing with 1 inch or 2 of insulation on the outside. It might be an integrated sheathing OSB product that has a laminated layer of foam to it that is certainly common in a whole bunch of states across the US. These are the type assemblies typically that we're talking about for wood frame construction, passive house projects to get us to meet the passive house standard in coastal California. Is that a surprise to anybody? Does anyone question that? I certainly was surprised the first I heard it. And the more digging you do on the numbers, the more math you do, the more studies you look at, this is where real passive house projects, how they're being built. There's some Q&A here. I don't know if you're answering those in the back end. There was a question here about what about steel? There's no doubt that it's harder with steel. But I guess the other reality is that we're incorporating continuous insulation already as standard design practices with our steel framed walls. So what we're targeting here is R values. The R values of these walls are effectively in the R20 range. R15 to R20 is effectively where we are. Our prescriptive requirement for wood frame buildings in California is between R15 and R20. So that same level of R value, the building doesn't know whether the walls are made out of steel or wood. We're targeting that same level of R value can get us to the same energy demand levels. So again, R15 or R20 with steel stud frame walls, we're probably talking 3 to 4 inches of exterior insulation on the outside of these buildings with bad insulation in the cavities. And that's maybe 1 or 2 inches thicker than what we're commonly doing on commercial buildings being built right now. So slight changes there, but nothing drastic. Another key aspect of passive house is air tightness. So the passive house standard requires 0.6 air changes per hour at 50 pascals as a whole building air tightness metric. Intuitively, that probably doesn't make sense to many of us. And if we look at the numbers in the Title 24 or IECC, we'll see a metric of 0.4 CFM per square foot at 75 pascals. Just keep in mind that these two metrics are calculated differently. The 0.6 ACH is a volumetric measurement. The 0.4 CFM that exists in our Title 24 and the remainder of the IECC and ASHRAE codes is a surface area based leakage rate. So you can't compare these directly. You need to understand what the ratio between facade area and building volume is to make that conversion between ACH and CFM per square foot. So that math can be done certainly, but appreciate that 0.6 air changes per hour is significantly more airtight than 0.4 CFM that's in current Title 24. So how hard is it to get there is a fair question. So a slide I've shown in many different presentations over the years. There's lots of ways to make an airtight building. There's a lot of different products we can use. There's a lot of systems on the market. There are a lot of manufacturers that will sell you an air barrier product. And the reality is all of these can work in a passive house context. We can make every single one of these systems, every one of these materials we can incorporate them into a system that gets us to 0.6 air changes per hour, which is the Passivhaus standard level of air tightness. There isn't a new material that we need. There isn't some new product or new expensive material out there that we need to incorporate into our projects to get there. It's the details that matter. Over and over and over again, I think we often overstress the product and understress the integration and the details. All of these products are extremely airtight in the center of the wall. When we interface with a window, when we interface with the foundation, when we interface with the roof assembly, that's where air leakage happens. So simple products with good details can get us to the Passivhaus standard. This is a building in Washington State. The 0.4 CFM, a square foot number that I mentioned that's in Title 24, frankly, is just not that hard to achieve. We haven't gotten to the point in California where we even test and verify that number on code compliant buildings. It's being discussed right now for future iterations of Title 24, but we're not, apart from a few projects here and there that have it integrated into their commissioning specifications, we're largely not testing this number. But we know from other markets that 0.4 CFM a square foot, if you're trying even a little bit, is not prohibitively difficult. Washington State recently reduced their air leakage metric in their code from 0.4, which is where California currently sits, to 0.3 CFM a square foot, and they've ratcheted down. And there isn't huge outcry there that the 0.3 is going to be that hard to meet. So I'd say that 0.4 number is kind of low hanging fruit. That 0.6 air changes per hour in the Passivhaus standard does take good planning and execution. That's going to be on the order of 0.1 CFM a square foot. We can do the math. It depends on the building. I'll put lots of caveats in there, but it's in that order of 0.1 CFM a square foot if we want to use the same metrics that exist currently in the code. It's all about the details, and simple geometry helps. All the ins and outs and the changes in plane and changes from one material and assembly to the other are challenging to detail and are challenging to execute. So simple helps. The products used on your last market rate job, code compliant job, work for Passivhaus too. This is a Passivhaus building in this picture. I think many will recognize that material there. We commonly see this on this product here on mid-rise multifamily buildings all across the Bay Area. You can see this brown, essentially loose sheet applied membrane all over town. We can get to Passivhaus standards with this. So we just need buy-in. We need to think about the details during design. We need buy-in from the construction and construction management team and the trades during construction, and the details matter. Okay. Here's that building finished up. 0.067 CFM a square foot at 75 pascals is what this building tested to as part of its Passivhaus certification process. So again, 0.4 CFM, the current number in the California code. Simple building with cost-effective air barrier materials on the outside. We can achieve really high levels of air tightness, in real life. It's real numbers here. Lots of guides out there on how you get there. I would point you to one of these that we helped author on behalf of BC Housing, the City of Vancouver, Province of British Columbia, an illustrated guide to achieving airtight buildings, talking about common details that exist largely on these multifamily buildings that pop up all the time. Lots of other benefits, Passivhaus too. We've talked or alluded to some of these before. Indoor air quality, having an airtight enclosure with ventilation systems that we can actively filter certainly helps with indoor air quality. In the smoky environment that we're in every summer now, that's a huge benefit. Acoustics and thermal are very similar. They are both driven by good acoustic performance is driven by continuity and lack of bridging. Sounds a lot like thermal performance, where we're focusing on minimizing thermal bridging and continuous thermal control layers. So thermally efficient buildings and airtight buildings are acoustically strong buildings. Odor control from unit to unit or from outside to inside. Energy savings, thermal comfort, I think we can all appreciate the chilly day that's happening in San Francisco right now at 55 degrees outside, and I'm wearing my heater's cranked and I'm wearing a sweater on the inside. So you know, we don't have to live like this, I guess, is my point. The ventilation question, alluded to this a couple times. This is a picture from the street in front of my house last fall. I don't know if anyone's from the Bay, I'm sure they remember this day well. This is 11 a.m. with smoke, you know, towering over the sky. Middle of the day, the street lights were still on down the street. This is the reality of the world we're living in right now. And if your house is like mine and is ventilated by open windows and exhaust fans from kitchen exhaust and bathroom exhaust, we're breathing this in too. And so from a livability perspective in our buildings, the ability to filter that air, that ventilation air that we need to breathe, is certainly benefited by the use of a ERV or an HRV to and an airtight enclosure, so that we are taking all our ventilation air through a mechanical system that we can filter and deal with the way we want. So ERVs, HRVs, standard in passive house buildings, they certainly improve our energy performance in all climate zones across California, help us meet those heating and cooling demand levels that we need to get to the standard. They drastically reduce, and in some cases, and again, there's a study in here that based on that previous study that I alluded to, you can actually eliminate your heating and cooling loads with the use of an ERV in some of these coastal California climates, and that's key. No heating or cooling systems in addition to an HRV that you're using to ventilate your building. It's really significant from a capital cost perspective, but also from an energy efficiency perspective. So I think we're heading this way already. A lot of these new non-passive house projects are starting to talk about ERVs and HRV in a more significant way, largely to deal with, you know, some of these smoke and indoor air quality issues that we're all aware of. So putting that all together, this is something that could work in most of our coastal California climates to get to the passive house standard. Efficient massing. We're going to talk about a little bit of that more later, but we want to minimize the surface area of our building enclosure compared to the volume or the surface area of our inside space. Building enclosures are expensive, and they're also where heat loss happens and heat gains happen. So minimizing that surface area to volumetric ratio is key. Wall and roof insulation meeting the current code requirements. Maybe with the addition of R4, R5, maybe up to R8, depending on the specific climate and the specific building form. Double glazed low E windows with low conductivity frames, fairly standard. Strategic glazing, reasonable window to wall ratios, airtight enclosures, HRVs for ventilation, heat pump, electric heat pump for domestic hot water. And if you want to add some solar panels on the roof, you can get the net zero energy quite simply. And we already have a full electric building in line with many of our local jurisdictional requirements already. This building can get to passive house levels of performance, can meet the passive house standard in most of our California climate zones. I suspect none of this is really, it seems that out to lunch to most people here. This seems like kind of good, thoughtful design, maybe some, you know, using some maybe the next generation of products from an ERV, HRV perspective for ventilation, but we're not reinventing the wheel here. This is not stuff that we haven't done before. Packaging all this together and doing it thoughtfully can get us to the passive house standard.
Right, thank you. So we're going to continue our tag teaming here. And what I'm going to try to do with these, I think that was a really great summary, and I think it's an important point that the numbers I've given, that 0 to 9% range, is from more northern climates. I do not anticipate it would be that expensive in California, and the relatively small delta between the coming window codes and the coming wall codes and the passive house requirements in most of those climate zones. And the reality that a centralized ERV with a little bit of pre-tempering for heating and cooling, such as the Swigen Mitsubishi interface, or Ventacity also has an interface with a heat pump provider, could really lower the overall upfront mechanical costs as well as the long-term operational costs in some of these projects. In this next section, I want to just kind of share two pieces of advice of framing around projects that I tend to share in our opening workshops on our first kickoff meetings with many of our Passivhaus clients. And again, noting that some projects are extremely price competitive. We're doing an awful lot of mid-rise affordability projects. We have a housing crisis and a climate crisis, same as in California, and we don't have the option of either or. We have to solve them both now. We're also working on some luxury Passivhaus projects where price is less sensitive. We showed a few of those earlier, but in this pursuit of affordability, please consider these two ideas. One, don't retrofit your last project idea or your last design to be a Passivhaus. That is the expensive path. And two, consider the new milestones you need to add as you build this. Your Gantt chart needs to have new pieces in it for a Passivhaus to be affordable. And let me just do a little bit more detail on that. So we talked about, again, in these northern districts, you know, the 0 to 9% range, but who cares, right? It's not the right number for California. And it's not a number that means anything to you. What you want to know is how do you get a project closer to 0% than closer to 9% as a constructive cost premium? That's the question I urge people to ask. How do I make my building more affordable while being better built and performing better? And so conceptually, you know, what you don't want to do is retrofit your last design. If you start with the same last multi-unit building you did, and many architecture firms in the multi-family space specialize in this, so they do building after building, they have kind of patterns that work for them. If you think of the worst building you were legally able to build last time around as the 100% baseline, and you add to that some additional insulation, some extra windows, high performance heat recovery ventilation, of course you're going to have a cost premium. How could it be otherwise? Now, again, you don't need 6 inches of insulation in your climate, so the cost premium might be lower, but of course it's going to go higher. If instead you think from the very conception of the building, I mean from the owner's project requirements, or at the very latest from the first meeting in schematic design, at simplifying the building itself and building a building or designing a building that is more amenable to Passivhaus detailing and ventilation strategies, you sort of shrink what would have been the code minimum building construction cost down in the range of 10%. Through strategies like limiting the window ratio, which really helps you with cooling loads, reducing the surface area by not taking on articulation that isn't fully required or that doesn't have a benefit for the occupant, and creating really compact mechanical cores and organizing your planning around your new ventilation systems that typically need more ductwork than, say, just a bathroom fan. Define these targets in the owner's project requirements or very early. And then on top of that, you add some extra insulation, different windows and doors, exemplary ventilation, and some of your other costs. This approach of simplifying at the gate and then letting the Passivhaus costs for quality, the investments in quality, is how projects like we showed a few minutes ago got to very low price points for Passivhaus affordable housing. Now, again, it's a different process when we're doing luxury high rises with different markets. I would note, this is a topic I talk about a lot. I've created a course called A Pattern Language from Passivhaus, entirely in the format of the classic book written there in Berkeley by Christopher Alexander and many others, and developed a whole set of patterns that we have seen projects doing affordable multi-unit Passivhaus apply again and again and again. And I'm happy to talk about teaching this with AIA in California or any other group that wants to kind of go through this list in a longer forum. But the first one on that, I just want to talk about now, and it's about setting milestones that meet your metrics. Most of the projects we work on have milestones. They're managed to financial milestones that have to be met. And so certain degrees of planning and primarily costing have to be done by certain parts. And there's municipal milestones. We have to do a rezoning application, development permit application, building permit application with certain dates that they're targeted. Unfortunately, many of those planning processes no longer include milestones that are actually about the building. And as we introduce new technologies, such as Passivhaus levels of performance, whether you're actually going for a Passivhaus target or something similar like our BC Step Code 4, having milestones that force the team to produce deliverables by a certain date is how we do Passivhaus design and construction with less drama and less finger pointing and revisions and pieces like that. And it really is that simple. So as samples. And of course, milestones are unique to every project, but these are some of the milestones we meet with teams and talk about adding to our processes at the very beginning. Working over the OPR, the owner's project requirements, is the most important one by far. And where owners are unclear about what standard they should go to or why, we're happy to meet with owners before the entire team's hired on a very limited scope and just talk through, here's the FIA standard, here's the International Passivhaus standard, here's the Living Building Challenge, here's where your Title 24 references are, or whatever else you want to look at. It's important for the owner to understand why they're doing what they're doing and how it would compare. I want to say this really clearly. We see OPRs go off the rails in a few different ways. The worst way OPRs go off the rails is when they ask for everything in the kitchen sink, but not to certify or not to actually do the due diligence. That's just an unreasonable statement that generally leads to higher costs because the consultant table all projects onto that airy-fairy OPR what they would like to do anyway. We urge OPRs to be very bloody-minded. And so instead, don't just say, we will certify to the International Passivhaus standard. Say, we will certify to the national standard. And these are some of the techniques and strategies we are encouraging the team to pursue as part of that standard. And in Paddling, we talk about some specific metrics around those. Once you know what your standard is early in the OPR, you can hire a consultant table that knows how to do that. And so you want to hire architects who have experience with these buildings, mechanical engineers who have experience with high performance buildings at the minimum, and Passivhaus buildings ideal. You want to hire a Passivhaus consultant who has multi-unit experience, has done more than just a single family home or two. But you can't know what you need to hire if you haven't set your strategy really clearly in the OPR. And of course, you're setting targets like this. When we work with new teams, at least for RDH, we insist on doing an integrated design charrette at the kickoff of schematic design. If the team has done multiple Passivhaus projects before, we'll waive this requirement, but we have never found a case this hasn't paid off. And the way we set up that design charrette is we do a preliminary energy model in PHPP or WIFI passive before this, based on a box model of what the site can absorb in terms of height, width, depth, number of units. And we understand that's not final. We take that box model into the design charrette and begin discussing specific targets. Here's the range your walls need to be in this particular spot. Here are some construction options. We'd like to hear from contractor, or at least the construction manager, on what works. Here's your mechanical solutions. Here's what will really bring your performance. We'd like to have the mechanical engineer at that first meeting to really talk through options. A key one being, are we doing centralized, regional, or decentralized circulation strategies, and what does that mean to operations? We basically go through all of the choices that are driven by the standard in the beginning of the first day. This has two effects. One, we can start getting accurate costing. Whoever's doing the quantity surveying or estimating early has a much more clear sense of what they're looking at, and they may have some comparisons to walk out of that first meeting. And secondly, it lowers the fear factor. Whatever might come up in terms of unique conditions that might be something the owner needs to think about, some choices, or something the architectural firm hasn't dealt with before and they wonder what they need to do. Out of this design charrette, everybody has a list of what's on the table, and there's very few surprises after that. After that, we come out of an early energy model based on the discussion there. And we understand that that first model is setting targets, not defining final assemblies. And so like an early stage budget, it needs a big buffer. Your first energy model ought to have in the range of a 20% buffer against whatever target you're trying to hit. And we talk about ventilation in the first meeting always. We cannot put off mechanical decisions on these. In the design development, we're often working with architecture teams who are accustomed to pulling detailed designs from a big book they have in the back, and they copy and paste many details they've been using for many years on many projects. What can make high performance buildings a little difficult is our attention on thermal bridging means we can't use the same details. And so the first time an architectural firm does a Passivhaus or another high performance project, it has to produce a bunch of details. They need to be reviewed by the Passivhaus consultant, typically modeled thermally at each detail. And there's typically some iterative process there. You can't start that halfway through construction documents. Because these are new details, it is essential that the architecture firm recognize this is extra work, somebody's got to do it, and it is cheapest to do early in design development. Even if we don't have the shape and the units completely set, we can start working on concrete to wood frame curve details right at the beginning. And by doing so, we allow time for iterative process, allow time for construction or construction managers to have feedback on how they would like to build it in a cost-effective way and develop better details. The good news is this is a one-shot deal. The architecture firm then can go to their second high performance or Passivhaus project with a set of details from the first one, and they don't have to do this again and again and again. But focusing on this in design development takes out a lot of drama and a lot of delay through the entire process. We typically finish design development with a second energy model that includes a smaller buffer, like 10%, because we now have specific details we've modeled. We're more confident of where things are going to be. So just like a financial budget, the buffer gets smaller as the model gets more specific. In construction documents, if we're going to certify the project, we try to get the details and the model to the building certifier before all of the construction document period is done, typically halfway through. This allows the certifier to review it before construction and issue a letter that some municipalities, such as the city of Vancouver where I live, and there may be others in the future, will literally require before you can get a full construction permit. But whether it's required or not, it's a huge piece of safety for the architectural firm, first and foremost, but also for the client and everybody else at the table. You've got a letter from your certifier saying, yep, if you build this building to these plans and specs on this site in this way, I will certify it. So they've taken a lot of the risk of the fear factor down the road out of the way. The critical piece is they need time to do that review. Your consultant needs time to put together the package for them. It doesn't happen in a week. It's usually a month or two of review, and the first one can take longer because there might be some back and forth. So you need to have a milestone in CD to talk about what date are we going to get the model to the certifier so we can get it back at a reasonable time. The other thing we do a lot during construction documents and first-time Passivhaus projects is look for inconsistencies. It's not at all uncommon to have, you know, the mechanical engineer and the structural engineer and the architect are all submitting standard details on different pieces that may or may not have caught the changes that are happening because of the high performance air barrier, the high performance way of installing a window or something like that. And so we work hard to comb through everything and make sure those inconsistencies are ironed out in the architect's office, not in the construction trailer, because we know it costs less at that phase. And we have robust discussion about what our value engineering process might look like. We encourage everybody all the way along to look at the value of the project, but we want to start many of those questions back at SD and DD, especially when it comes to major components like windows and ventilation systems, not start it at pre-construction. The Passivhaus construction kickoff is as important to construction as the integrated design charrette is to design. It is the second pillar. We push hard for first-time teams to make extra time, not only with the general contractor, but with key trades and allies to make sure everyone has the chance to go through some of these critical details that the architecture firm has worked so hard to create, and that they understand them. This typically involves construction mock-ups and some training of site workers and establishing a clear communication path between on-site observations, site visits, and checking back with key engineering consultants like enclosure consultants and the architect themselves. And usually around this time, we're getting our design stage approval back from the certifier or from the certifying body. And 5% buffer is plenty at this point because everything's been ironed out. As we move into construction, we have a good plan for site visits and testing. And again, it depends on the construction technique. Colin was really detailed a few minutes ago about air tightness. The great thing about good air tightness is that it doesn't cost you anymore. It's a construction quality assurance, quality control process, not a need to apply extra stuff. And so it's one of the easiest ways to improve performance. And we would note that while many teams have a lot of fear around construction, you have this huge advantage that it's easier on a building with large volume. Our multi-unit buildings, even though the target is only about 0.6 ACH, most of our multi-unit buildings are 0.2 or 0.3 because it's just not that difficult to do. So fairly typical reviews, adding ventilation commissioning. And this is one of the key pieces people aren't used to. Where you put in a high performance central ERV system, you need to come in and prove not only that it's designed to flow at say 10 CFM out of this vent or 20 CFM into that vent, but you're actually putting a hood over each one and making sure it does. It's important that the mechanical engineers, that the mechanical contractors, right down to tin bashers, completely understand this and are prepared for it, and that there is planned in ventilation commissioning, which sometimes need to be done in phases, because you'd want to do some of it before it's all drywalled up, because if you have a problem, you don't want to start ripping into your walls to fix it. So again, it becomes a milestone issue, understanding when you're going to do parts of that commissioning. And then finally, into the milestones, we set projects, programs to train residents and managers so they understand what they're getting at the end of the day and how to operate it. Produce final packages, install a plaque, and we like to do debrief meetings as much as possible. I present these, and you're welcome to snip this slide, to take it from AIA, to modify it. These are samples of the kind of milestones we work with teams at the very beginning to put in their Gantt chart and talk about where they go on this project. They're not perfect. We customize them for every single project, but feel free to start with this as a template. I guarantee you, if you put many of these into your own milestones, you will have a more drama-free first high-performance project. Back to you, Colin.
Monty, any questions in there that in the Q&A that you want to tackle as we do the transfer here, Monty?
I can't look at the questions and talk at the same time, but I'll take a look now.
You're off the hook for a little bit. Maybe we'll maybe some things in here you want to talk about as we go through this last section, but we're nearing the end, and I'm hoping we have some good opportunity for Q&A at the end. So,
I'm going to take up the anonymous attendee question because I love it. But, what are the aesthetic reactions of occupants? It depends on the building. And I want to note again, these approaches to milestones and to simple enclosure help affordability. If affordability and climate are the two things we're really working on here, affordable housing that will not produce greenhouse gas emissions and will defend against smoke, defend against increased heat and humidity, this affordable Passivhaus approach makes a lot of sense. We have other projects where aesthetics are the driver. We're doing luxury projects like the 60-story Nelson Tower and sort of some beautiful mass timber Passivhaus projects. So it really depends on the client's expectation of aesthetics. I would just say that for an awful lot of people here, they would make a heck of a lot of trade-offs on aesthetics to get a house, to get a nice 2-bedroom or 3-bedroom apartment. And so I just think it's a question that comes up project by project. I am really proud of the aesthetics on some of our higher end projects, but they're not coming in at $200 a square foot. Those more aesthetically different projects are in Canadian dollars, 500, 600, 700 bucks a square foot.
Thanks, Monty. 3 key takeaways. If you've not heard anything else for the past hour, these are 3 things that can make our lives easier if you start working on a Passivhaus project, or really truly any project that you want to be truly high performance in real life, more than just on paper. Because I do think in many cases there is a fairly big disconnect between our modeled energy performance and our real energy performance, particularly on projects that don't have some sort of certification process like Passivhaus, which I do think is one of the advantages. It holds us to something. Plan mechanical first. Monty's talked about that a little bit. Simple form factor and reasonable glazing. I don't know where this picture is from. I guess it's from Energy Vanguard, but I don't know where this building is or whether it was done as a farce, but it paints an interesting picture nonetheless. Poorly planned ventilation systems. We talked about the need for HRVs and ERVs. Poorly planned ventilation systems cost more to install, cost more to maintain, and bends and twists and elbows and ups and downs cost energy and efficiency. So thinking about these early, figuring out where those straight, simple runs go saves a lot of headaches. We need to start with this in mind, as Monty mentioned early on. We can, but it's challenging and expensive, and it's hard to get good performance by shoehorning a mechanical system into spaces that aren't suitable for it. So we need to start with the mechanical system, figuring out whether it's central or localized, or and where the various zones are going to be, and we need to do our space planning around that with that in mind. Remediation of these poorly poorly planned mechanical systems is a leading source of change orders, headaches, costs, schedule, all of those things that we are constantly fighting against during the CA phase. There's a huge amount of planning that needs to go in here from the mechanical perspective. We need efficient HRV systems, well-insulated domestic hot water pipes, and right-sized cooling and heating systems. That's a common thread of what we've been talking about. Minimize the loads and design efficient mechanical systems to meet those lower loads, right? But there's a spatial aspect to all of this that we need to think about early on. Going back to Monte's timeline of values, that integrated design charrette talking about the space constraints of those mechanical systems pre-SD or early SD can save a lot of headaches. That shoehorning approach is not a fun one. Lay out the mechanical space first. Identify that ventilation strategy, local or localized or central, as we just talked about, early in SD, figuring out where these units and ducts are going to be located in the floor plan. If we go with a local HRV strategy, they need to be tied to exterior walls and all those units. If we go with a centralized system, there's different constraints around where ducting can go. So mechanical does have a fairly significant effect on from a layout perspective. Minimizing pipe lengths and runs. Short domestic hot water runs are less capital cost up front and more efficient to operate in real life. So right sizing these systems, understanding all of this layout perspective does drive efficiency. It drives sizes of pumps. It drives how much loss happens throughout the transportation of all these air and hot water. So think about that early. So local HRVs, maybe in a closet or something on an exterior wall would be one approach versus a centralized or rooftop mounted HRV. Monte mentioned some Ventacity systems and others that exist on the market that are fairly suitable centralized systems for these multifamily projects now. The supply chain of these products has gotten quite a bit better in the last number of years. Monte mentioned that Cornerstone project where there was really only one option for an HRV that would work. That's slowly changing. There are more options in the marketplace now, which is great. Okay. Lay out the mechanical first. Have a mechanical engineer on board who's ideally done a bunch of high performance projects or done Passivhaus specifically before. Think about this stuff early on. We'll skip over this and hopefully get to some questions. Minimize surface area. This is a project in Montreal that certainly won a bunch of awards back in the late 60s, if I recall. Maybe you like it, maybe you don't. But the pattern language book that Monte alluded to, wrinkle the edge, turn the corners to achieve light on two sides. Many planning guidelines were constantly trying to break up massing, step back roofs and decks and additional corners and ins and outs and bumps to give these buildings, architectural and aesthetic appeal. All those create cost and energy challenges. So we need to do that. Sometimes we have to do that. We don't want to build, boring boxes necessarily, but do this with intention and keep in mind that there are trade-offs to doing this. Pretty hard for this building, probably that we're showing here to go get to Passivhaus levels. There's just too much building enclosure area. There's too many ins and outs to make it practical. This is a quote that I like from a contractor who's worked on a number of Passivhaus projects that Monte's worked with on several projects. I think this is spot on. It's all about the shape, both for performance and cost. Decorate the envelope, don't decorate with the envelope. I think this is where people go wrong. So geometry, simplicity, it's good in a lot of levels. We talk about keeping water out of buildings and durability. Simple works there too. Simple works from an energy perspective. Simple works from a cost perspective. And I think we need to challenge ourselves to make simple beautiful at the same time. Bays, step backs, balcony inserts, all those things that we talk about, that we just talked about. And I think we can appreciate from a geometric perspective add up. So I'll let you guys read all this text, but I think this example is telling, right? If we have a 4-corner, or if we had a 6-sided box, if we wanted to look at this in 3D, and we start keeping the same surface area, but changing the shape of that surface area around a little bit. 4 corners is inexpensive and is fairly energy efficient. That's maximizing our ratio of volume to surface area, minimizing basically the amount of building enclosure. As we add more corners, we add cost, we add more structural material. We have 3 and 4 stud corners at all of these changes in plane. We add more surface area where we can either have heat loss or heat gain. We add cost. We add, talk to a drywall or siding contractor. One of their first questions is, how many corners do I have to do? Big straight runs are efficient and inexpensive, right? So these decisions here about massing affect cost and affect what we have to do from a building enclosure perspective. These result in additional layers of insulation and other things like that. So every corner counts, every corner costs, and all these additional things that we have to do to make complex geometry work add money too. So here's some massing layouts on a building in Vancouver that went Passivhaus. Simple massing versus those ins and outs that we commonly see. There are energy and cost penalties to doing that. So not saying you can't go Passivhaus with this increase in 10 on the right. You certainly can. It's just you're making it more of an uphill battle. It's harder to do that as we get more complex geometry. So this is something to think about early on as you're talking about massing, and certainly from a zoning perspective as well. Okay. To the OPR concept that Monte was talking about previously, set a surface area target and require the design team achieve that target. Evaluate the form demands of your site, set a target. So that surface area target and that ratio of 1:1, 1:1.3, not hard numbers, but minimizing that surface area to floor plate ratio certainly helps make your life easier. Glazing in lieu of design. This is from Monte's pattern language course on Passivhaus. Glazing in lieu of design versus glazing as design. So we want conceptually, in a perfect world, we want windows to answer to a function. If there's a reason to have a window there, by all means, right? When we need windows in our buildings, we want windows in our buildings. But is the size and location of the window serving a justifiable purpose if our goals are energy and affordability? And in some cases, we overglaze. So, these buildings certainly are very nice to look at, complicated, complex, really fun to work on from a facade engineering perspective. I work on buildings like this all the time. They're interesting. But certainly challenging from an energy perspective, and they're certainly not cost effective if our goal is to, provide affordable housing. So does the window perform a function? Does it answer to that function? This is the city of Vancouver's skyline. May not like the look of all this glass and window wall aluminum that exists across the city of Vancouver. Eye of the beholder, perhaps. But I think the telling thing here is, look how many blinds are closed. Occupants are telling us they don't want that many windows. There's occupant comfort issues. There's solar overheating issues with these buildings. How many of these windows are open on a regular basis? Far fewer than actually exist in real life. So I suggest to you that we don't need 75 and 80% glazed towers. We could replace a lot of this glass with less expensive and more thermally efficient opaque facade systems, and still come up with really beautiful looking facades. I'm not suggesting we should have window to wall ratios at 15% and we should be building, communist block housing from the Cold War. But reasonable window to wall ratios in the range of maybe 25 to 40% are very reasonable. And we can have reasonably sized punched window openings. We don't need daylight at our toes most of the time. So here's an example of really windows performing a function and really being sized to suit the specific space here. So this is a gym at Cornell Tech. This is on an island looking over to Manhattan. fairly small windows, but if you're on these equipment machines, they do still give you really striking views of the skyline in downtown Manhattan, or uptown Manhattan, I guess in this case. So we don't necessarily need floor to ceiling glass that has cost and energy perspectives, but we can still get really creative with our design and still give ourselves the lighting benefits and the daylighting benefits while still managing cost and still managing thermal performance at the same time. Okay, so again, this is this building here is a Passivhaus multifamily building. I don't think anyone would suggest that these look drastically different than the multifamily buildings we build now. This is not like we're cutting window to wall ratio to unreasonable levels. But again, specify that window to wall ratio early, be reasonable with it. Windows are expensive and bad thermally, both from a solar heat loss perspective and a solar gain perspective. So use your windows with intention. All right, we have a few minutes left. Monte's been typing away, I know, at these questions, which is great. But if there's any lingering questions in our last 8 minutes or so here, we'd love to chat further.
That was a great presentation, gentlemen.
There was a good question that was left open about, are these costs reasonable? And again, I want to be just really clear. The costs I gave were for projects focused on affordable housing. And they were making lots of compromises from a design viewpoint. Most didn't have balconies or pieces like that. And that's how they hit those rates. We are working on Passivhaus projects from, I would say the lowest rates are in that $200 a square foot range up to one project that is going to be in excess of $1,000 Canadian per square foot. So it really depends on the context. But the principles of simplifying apply at all buildings, and the principles, that the kind of timeline pieces we showed are the same tools we use to reduce drama in large expensive projects, the same as in small projects.
This is a question for either of you. How do you convince your client not to use glass?
It's a discussion, and it's certainly an active topic within architecture and development. I mean, Vancouver is famous as being a city of glass walls, mostly glass curtain window walls. I don't really feel I have to convince everyone. I think climate change is doing it for us. So many of these buildings are already facing overheating problems, even here in Vancouver. Really, you want to know there's overheating problems in Vancouver? Look at the listings for condos in August. They disappear, and then they put them back on the market in September because they don't want to show them in the summer. So the overheating problems, the very high cooling loads, the very high heating loads, that as those buildings are facing replacement, they're already looking for ways to change that aesthetic. So while there's certainly always going to be a place for some really striking, iconic buildings of all kinds of technologies, as we look for more housing that is an architecture for the Anthropocene, we have to be looking at more bris de soleil, less glass curtain wall. It makes sense from a use of energy perspective. It makes absolute sense from a greenhouse gas emissions perspective. It makes sense from a durability perspective. There's just, we don't have to make this case. You just have to take climate change seriously, and you're going to look at using less glass. But I want to be really clear about this. There are specific reasons to use glass. Views are important. Daylighting is tremendously important, and natural ventilation is tremendously important. So where those purposes exist, we should absolutely be inserting windows. One of the things we talk about in pattern language is actually going around the building and just looking at each window and say, what purpose does it serve? And those are the big three. There's others. If it serves a purpose, it stays in. But if it's just there for a design and it's kind of covering the space between floors or something else, it's worth reconsidering.
I guess I would add in that in my local context here, most of the multifamily that I've worked on, be it mid-rise or high-rise, both, we're not commonly doing silly amounts of glazing most of the time in the San Francisco market in the housing, and I think it's largely cost-driven. Glass is expensive. Vancouver is a bit of an anomaly, relatively speaking, I think, Monte, in that there's a lot of fully glazed tower residential projects in Vancouver. But I'm working on a twin tower, 15-story multifamily building right now that has a window to wall ratio of in the high 30%. And there's no aggressive energy targets. It's just right. That's what they're doing. And that's what seems normal. And again, I don't think that number's out to lunch from an overall performance perspective. So different styles of buildings and different locations are going to have, different pills to swallow. But I don't think necessarily it's a drastic change.
It's worth paying attention what's happening in Europe on the nearly zero energy buildings initiative from the EU. And of course, this gets applied differently in every EU nation. It's not universally applied, but in some regions of Switzerland, for example, if your glazing ratio goes above a certain percent, you have to do exterior shading. It's not an option. They're just saying exterior shading of some sort of movability. And there's much more exterior shading that's more common there and more available in the marketplace. Or if you're going to do a certain amount of cooling load, you have to do exterior shading. And so recognizing that with increased glazing comes increased responsibility for exterior shading or brise de soleil or something, I think is a reasonable approach.
Thank you. We just have a few minutes. There was one question posted in the chat box that didn't make it in the Q&A. It's from Chris. When considering real estate value of capital improvements, what's the appraised premium in an asset valuation?
Well, we live here in Vancouver in a truly insane real estate market where anything you can get out to the market gets bid on with multiple bids. We're going through an intense escalation of prices right now that we're just scratching our heads over. And when something is such a seller's market, there is no premium for Passivhaus or high performance building that anybody can discern because the seller's market's there. There was a great study done in California some years ago, about a decade ago, on the value of green homes, where they tracked Energy Star and LEED and some other projects, and they found the similar thing. When it became a buyer's market, as it did in around 2008, you saw both a price premium and an ability of buildings with green sustainability features. They sold faster and they sold for more. So when the buyer is in control, there is a price premium. When the buyer is not in control, there's no evidence of a resale price premium. Now, the exception is with rental. And we have several projects that are doing multi-unit rental. Their business plan has been to build these Passivhaus buildings, operate them for 1 or 2 years to prove the cap rate and argue for a larger cap rate when they flip the building to institutional investors. They've been very successful. The funny thing is, several of our early projects that built with the intention of flipping institutional investors were so impressed with the cap rate and the rising rental rates here, they decided to hold the buildings rather than resell them.
Excellent. Well, that brings us to our hour-and-a-half time frame, and we'd like to extend a great thank you to Colin and Monte. We certainly did dive deep into the details, and we all appreciate that. Again, those of you who have stuck with us to the end here, AIA California staff will submit for your AIA CE credits. And also the Q&A will be included in the recorded and online content after this presentation. Thank you. Have a good
Thank you for having us, Robert. I appreciate it.
Thank you. It's been a real joy.
Thank you.